Hello again. Today we're going to be talking about the standard normal distribution. So let's get started. Let's say there was a normal distribution. We've talked about these before, and there was a mean associated with it and a standard deviation associated with it. We can create the following curve where mu, our mean, is in the middle, and we go out stepwise to the right and add sigma. And we go stepwise to the left and subtract sigma to get those x values along the x-axis. And so we'll notice that the data is spread with these percentages consistently. So we know that 68% of the data will always be between mu minus sigma and mu plus sigma, which we say is within one standard deviation of the mean. And 95% of the data is within two standard deviations of the mean. And 99.7% of the data is within three standard deviations of the mean. All right, so every normal distribution looks like that, but every normal distribution can be modified to look like this one where the mean is now 0 and the standard deviation is 1. So on the right, I go up by 1 and then 2 and then 3. And then on the left, it's -1, -2, and -3. But the percentages are still the same. So this is what's called the standard normal distribution, and I need a way to convert from my distribution to this distribution or back and forth between the two. But this standard normal distribution has a mean of 0 and a standard deviation of 1. So let's talk about how to convert between my distribution and this distribution. There's a formula we can use, and any z-score will equal any x-score from my distribution minus my mean of mu over my standard deviation of sigma. So this allows us to see how many standard deviations above or below the mean a score actually is. All right, so let's look at an example of how we can use z-scores to compare things. In 2017, Marcus took the SAT in Wyoming and scored a 1280. And at the same time, Laurie took the SAT in Texas and she scored a 1220. Now, just looking at those scores, it looks like Laurie did worse than Marcus, but let's see who performed better in their respective state. Well, here are the mean SAT scores and standard deviations from those two states. And so what I'm going to do is take each score and convert it to a z-score for that state. So since Marcus is in Wyoming, I take his score of 1280, subtract the mean of 1230, and divide by the standard deviation of 176, and I get 0.284. What that means is his score is 0.2 standard deviations above the mean. So very, very close to the mean. But then I look at Laurie's score. I take her score of 1220, subtract the mean for Texas of 1020, and divide by the standard deviation for Texas, which is 193, and I get 1.036. So her score is more than one standard deviation above the mean for her state. So comparing those students to the states where they took their test, even though Laurie scored lower overall, her score compared to other Texas students is better than Marcus's score compared to other Wyoming students. All right, so here's how you would find a probability between any two z-scores. So what you would do is you would go to statistics, and you would go to F5, which is distributions, and we would go to F1, which is your normal distribution, and then we would go to the normal cumulative distribution because we are trying to find a probability between two x values or z values. Let's say I wanted to know what percentage of the data was within half of a standard deviation of the mean. So my lower would be -0.5 and my upper would be 0.5 because I want to know what's within negative half a standard deviation and positive half a standard deviation of the mean. I make sure that my data is variable. I put in the lower and upper of -0.5 and +0.5. And since the mean of a standard normal distribution is 0 and the standard deviation is 1, I input those values. And so what the calculator gives me after I press execute would be the probability of being within half a standard deviation of the mean. All right, so that's a simple process for finding out the probabilities between z-scores. We're going to figure out how to apply that in the next lesson to some actual word problems because there is a meaning behind this. So you'll figure that out in the next lesson. So if you have any questions, please let me know, and I will see you tomorrow.